You ever look at some amazing invention and think, how on earth did they come up with that? It seems like magic, right? Well, it's not. It's a process, a really cool one. And today, we're going to pull back the curtain and show you exactly how it works, all through the lens of one incredible design challenge. So, every great engineering story kicks off with a challenge. And wow, this one is a real beast. The task? Design a wheelchair for rural environments. Now, hold on. We're not just talking about any old wheelchair. This is about creating a lifeline, a tool that gives someone freedom in some of the most difficult places on the planet. I mean, just that one sentence, it's packed with a whole universe of complexity. See, this is what's so important to get. Amazing engineering. It's not just about math and metal. It always starts with a person, with a real human need. This isn't some problem in a textbook. It's about designing something for a real person in a real place, facing real challenges every single day. And this is where the rubber meets the road. That human need gets translated into a list of really tough rules, the must-haves. Like, it's got to be able to roll over 5-centimeter obstacles, think like a chunky tree root. It has to handle slopes up to 10 degrees. And get this, 80% of it has to be made from stuff you can find nearby, so it's actually repairable. Oh, and it's got to fold up for transport, and here's the kicker, costs less than $220. I mean, any one of those is a headache. All of them together, that's a serious engineering puzzle. So, looking at all that, where do you even begin? It feels like a total mess, right? You've got performance fighting against cost, and durability fighting against weight. It's this tangled knot of problems. How do you even start to pull on a thread? Well, here's the secret. You don't just jump in and start tinkering. You pull out a map. And this is it. This is the engineer's roadmap. Instead of just wandering around in the chaos of the problem, they have a structured process. It's this proven step-by-step journey that takes them from, oh my gosh, this is impossible, all the way to, okay, here's our winning design. It's how you take a mountain of a problem and turn it into a series of hills you can actually climb. Okay, so let's walk through the 4 phases on this map. First, you define. You basically write down all those rules of the game we just saw. Then comes analyze, and honestly, this is the part a lot of people skip. You forget about what it looks like, and you just ask, what does this thing have to do? What's its job? Then you get to generate. This is the fun part, brainstorming a bunch of different ideas. And finally, you evaluate. You take all those cool ideas and hold them up against your original list of rules to see which one actually makes the cut. Okay, let's zoom in on that analyze step for a second, because it's super important. It's called functional analysis, which sounds fancy, but it's really just about thinking in verbs instead of nouns. So instead of saying a wheelchair needs wheels, you say it needs to move the user. Instead of brakes, you say it needs to slow down safely. See the difference? When you think like that, you're not stuck with old solutions. Your mind is totally free to come up with something brand new. All right, so you've done the logical, structured part. You've defined the rules, you've analyzed the functions. Now it's time for the magic. This is where you get to let loose and get creative. It's the moment the process flips from pure logic to pure invention. But here's a little secret most people don't know. Even the creativity part has a system. Engineers have actual tools to spark invention when they need it. There's this myth that engineering is all just numbers and physics, right? Cold and calculated. No way. It's a deeply, profoundly creative field, and they've developed tools to help fire up that creativity on command. How do you systematically invent something? I know it sounds totally contradictory, right? Like scheduled spontaneity, but it's a real thing. Instead of just sitting around hoping for that aha moment to strike like lightning, you can actually use mental triggers to push your brain down new and unexpected paths. And here's one of the most powerful toolkits for doing just that. These are called creative triggers. Just think of them as a list of questions you can ask yourself to shake things up. Like, what if I substitute this part for something else? Or what if I combine these 2 ideas? It's not just random throw spaghetti at the wall brainstorming, it's guided invention. So let's actually try this with our wheelchair. Let's pull the substitute lever. Okay, a wheelchair frame is usually made of metal. But wait, one of our big rules is using local materials. So what's a material that's super strong, pretty light, and grows all over the place in rural areas? Bamboo. Boom. Just like that, by asking one simple question, we have a whole new design idea that perfectly fits one of our toughest rules. Okay, let's pull another lever. Combine. Think about it. When someone's pushing the wheelchair, they're creating energy, right? The wheels are spinning. What if we could combine that motion with another huge need? Like, what if the spinning wheels could also power a tiny water filter? It sounds a little nuts, I know, but that's the point. This is exactly where those game-changing ideas come from. All right, one more for fun. Put it to other uses. At its core, a wheelchair is just a strong frame that holds a person up. So what else could that frame do? What if you could unfold it or rearrange it so it becomes a simple cot to rest on? In a place where resources are scarce, making one object do 2 or 3 jobs is huge. You see how powerful this is? These aren't just random thoughts, they're creative solutions generated by a system. So this whole mindset, this combination of a strict process and these wild creative tools, this doesn't just happen by accident. Engineers are actually taught to think this way from day one. It's baked right into their education, and there's a really important reason why. And in the US, a big part of that why comes down to an organization called ABET. The easiest way to think about them is that they're the ones who set the standards for engineering schools. They literally write the playbook that says, by the time you graduate, an engineer needs to know how to do this. And here's what's so cool about it. ABET's rules aren't just, can you do the math or do you know the physics? Not at all. They go way beyond that. They actually require schools to teach engineers to think about the context of their work in the real world. And this right here, this quote says it all. An engineer needs to understand the impact of their solutions in and listen to this, global, economic, environmental, and societal context. That is huge. It means it's not good enough for your invention to just work on paper. It has to actually work for real people in their real lives. And bam, this brings us right back to the beginning. All those tough rules for a wheelchair, the low price tag, the local parts, the fact that it has to be repairable, now they make perfect sense, don't they? They're not just random technical specs someone made up. They are a direct result of this core ethical principle. The design has to fit the world its user lives in. So once you've got this incredible toolkit, this mix of disciplined process and structured creativity, you can point it at almost any problem you can think of. The wheelchair we've been talking about, that's just one example. This same thinking is being used to tackle some of the biggest challenges on the planet. Like, how do you keep life-saving vaccines cold where there's no power grid? That is a massive life-or-death problem. You use this exact same process and you end up with things like solar-powered refrigerators for clinics in the middle of nowhere. Or what about protecting endangered animals from poachers? The challenge is to build a tracking device that's tough, light, and runs for years. The roadmap to get to that solution? It's the same 4 steps we just went through. Or how about getting modern medicine to remote villages? You need a simple diagnostic kit that anyone can use, even without an internet connection. The journey to creating that kit starts with the very same process: define, analyze, generate, evaluate. So when you boil it all down, it leaves you with a really powerful idea. This way of thinking, it's not just for engineers building bridges or robots. It's a toolkit anyone can use to take a messy, complicated problem and start making real progress. So the question I want to leave you with is, if you had this toolkit, what problem would you solve first?